Hello. In this case-based study, case 1, here a silicon PN junction diode recommended here resistor R, give the diode etc. per meter, and battery voltage is VB, milliampere current. Here PN is the knee voltage. Below knee voltage, dash voltage like graph forward and reverse biasing here. Forward biasing here because forward biasing. So this is the forward biasing current in milliampere and positive voltage applied here from 0 up to certain extent. Very small current is there, almost nil, very small. But after the knee point and knee voltage, suddenly it increases like after that 1.1 or 1.2 volt in case of silicon. Saturation current comes here. So this is the active region, this is the cutoff region, is the active region. After that it is saturation region. So here in this question, knee voltage 0.7 volt is for silicon and minimum current required here 1 milliampere. So for protection, resistance is connected. This basis we are discussing now question 1. Here question 1, battery voltage 5. What is the maximum value of resistance in the circuit required here above the point? R equal to resistance required here V voltage, battery voltage 5 minus knee voltage 0.7 volt divided by current 1 milliampere. So that comes here 4.3 10 to the power 3 or 4.3 kilo ohms. So option here is 2 correct. And now question 2. Battery voltage this are required here to establish 6 milliampere. In this case minus 0.7 upon 6 milliampere current. So if we solve it here 10 to the power 3 ऊपर जाएगा. In that case 7 ohms required. So option 2 is correct. If the battery voltage 6 here, our will be VI, which 6 minus 0.7 the effective voltage multiplied by the current 6 milliampere. It comes here 5.3 into 6 means 31.8 milli. Option 4. Now question 4. Total potential, the forward biasing opposite polarity, the subtraction, but in reverse biasing addition because of same polarity, the total potential or total voltage will be equal to here 6 plus 0.63. 6.63 volt. So option correct. Now odd part, all the three, 1, 2, 3 are correct for PN junction diode, but it is having only 2 terminals, not 3. So here option 4 is correct. So this is wrong state. Case 2, rectifier is a circuit which convert AC to pulsating DC. We can rectify it as well as we can filter also. It will be at approximately pure DC, but without filtering it is pulsating DC. Here, if diode is forward biasing, it conducts, reverse biasing, it not conduct. There are two types of rectifiers, half wave and full wave. This half wave, so half wave is rectified here. Only positive cycle will be rectified, passing diode and negative cycle is blocked. But in full wave, there are two diodes D1, D2. So forward biasing, positive half cycle D1 will work, D2 not work, and for negative half cycle D2 work, D1 is not work because reverse biasing. So here output voltage will be full wave is rectified in 1. So here in half wave rectifier, if you can see input AC frequency here is 100 Hz. The output frequency will be the same. In full wave will be double. But positive negative cycle, one cycle, there are two cycles here. Then full wave, it will be 200. In half wave, it is 100 only. So option 2 is correct. Question 2. In half wave rectifier, during the first and third half cycle, only for positive half cycle, it conducts. So we are getting the output in first, third, fifth, seventh half cycle. For negative half cycle, it will not work. So option 1 is correct. The RMS value of sinusoidal input to full wave rectifier is this: V0 by 2, and RMS value, the rectifier output will be the same. So option 1 is correct. Now question 4. An alternating voltage 350 volt and 60 hertz applied on a full wave rectifier. So this is the RMS value 350 and the peak value will be this 350 or 60 hertz. The internal resistance here is 200 and the load resistance is 5 kilo ohm or 5000 ohms. We have to find the peak current, maximum current. Here we have to find the voltage divided by total resistance 500, 5000 plus 200. We solve it, we are getting the current 0.092 ampere, means option 1 is correct. Now our part. Here sinusoidal wave 220 volt applied and this is the half wave rectifier and we have to find the RMS voltage across the R1. Load resistance here is R1, so we have to find the RMS voltage. Here RMS voltage is given is VRMS for half wave rectifier is given by V maximum divided by 2 and V maximum will be 222 divided by 2, that will be 110 root 2 volts. So option is correct. In this case 3 here, motion of charge carriers, the helium-filled balloon, like say in P region holes are there, in N region electrons are there. So majority carriers, holes and electron, both are moving in forward direction like this. So the diffusion current, and due to the minority carriers they are moving in opposite direction, so this is the drift current. It's true for holes as well as for electrons both. So here diffusion current and drift currents are there. When equilibrium reached, both are equal and opposite, so now there's no further diffusion and drift, or if they are इक्वल एंड अपोजिट. तो अब ये फाइनली पीएन जंक्शन डायोड फॉर्मेशन हो गया. अब करंट, ओवरऑल करंट 0 है या दोनों करंट इक्वल अपोजिट. नाउ ऑन द बेसिस ऑफ दिस क्वेश्चन 1, silicon is doped with which type of impurity to get the p type? Germanium is semiconductor, it cannot be doped. Phosphorus and which pentavalent, so it will give you n type. Only gallium is there, it will give trivalent and it will be making the holes. So it is p-type semiconductor. Gallium is required as impurity. 2. A semiconductor has electron concentration Ne is 6 into 10 to the power 22 per meter cube, and hole concentration here, hole concentration will be 8.5 into 10 to the power 9 per meter cube. Here N is more than NH, so it is N-type semiconductor. N-type semiconductor, option 1 is correct. Question 3. In PN junction diode, current in reverse biasing condition is very small, of the order of microamperes. So option 1 is true. In forward biasing, milliampere range is there. In reverse biasing, microampere current. Question 4. In the middle of the depletion layer, reverse biasing PN junction diode, electrical field is given by voltage across the barrier divided by the depletion width. But in reverse biasing, resistance is quite high, of the order of mega ohms, ideally infinite, so very high resistance and depletion width increased. So because of increment in the depletion width, electrical field is very weak, very less or almost zero. So option here is 1. 1 is correct. Now all type in forward and reverse biasing, diffusion current in forward biasing dominating and drift current in reverse biasing. Unbiased condition, both are equal and opposite. So option 2 is correct. So in this case, when diode is forward bias, is our knee voltage. After the knee voltage, conductivity is very high. So current is rapidly increases like this. Forward biasing current after the knee voltage suddenly increases and then saturation. So here after the knee voltage it is increasing after say 1.1 or 1.2 volt, it gets the saturation. So current is not increasing but almost constant. So here knee voltage N or Vk, sometimes knee K and double knee voltage. In forward biasing milliampere and reverse biasing microampere currents are there. Now here question 1, forward biasing means the P region is voltage more than N region. Whether it is positive or negative doesn't matter, but P region voltage must be more than N region voltage, and it is true for third case. Anode voltage or P region voltage plus 7 volt and N region is plus 5. So that option 3 is correct. Only this is the case which is forward biasing, or other cases are reverse 0 plus 2 minus 10 0 like plus 2 7. So 1, 2, 4 are the reverse bias, only third case is the forward bias. Now question 2. Based on VI characteristics of the diode, we can classify diode is non-ohmic because graph is forward biasing also and reverse biasing also. Graph is non-linear. So it is the non-ohmic factor. Then 3 is the VI characteristic curve. And 3 VI characteristic curve. Here ratio of forward to reverse bias resistance. So forward biasing resistance is given as, in forward biasing, change in voltage 0.8 minus 0.7 upon 20 minus 10 milliampere. This it is 0.1 divided by 10 into 10 power minus 3, it will become 10 ohms. And the reverse biasing voltage difference is 0 minus 10. So 10 divided by microampere is here 10 to the power 7. So ratio forward and reverse biasing will be 10 upon 10 to the power 7. Is 10 to the power minus 6. The ratio here. So option 4 is correct. Now question 4. This is the direction of current in case of for P junction to N. So from P to N, ये current होगी forward biasing. So conventional current is from P region to N region. That's why symbol is like this. N junction diode का symbol भी है here. So option 4 is correct. Or part here the current is given by voltage difference 3 minus 1 upon resistance 100. So this current will be 0.01 ampere. So option 3 is correct. Is 5. Here this is the arrangement of studying the VI characteristics curves, figure A and B. Figure A is what? Forward biasing. Positive is connected to P region, negative to N region, and this is the opposite. So this is the reverse biasing. And graphs are plotted here like this in forward and reverse biasing. And this is the knee voltage here. It is roughly 0.2, like the breakdown voltage here is roughly 90. Thereafter that current in reverse biasing in microampere suddenly increases. 1. The voltage at which the forward biasing current increases rapidly, that is called the knee voltage. So option is correct. You can see the graph also like this. After 0.62 volts knee voltage, it suddenly increases. In PN junction diode potential barrier is due to the charges on either side. They are fixed. Donor and acceptor ions, they are heavy ions, they cannot move, so they are called immobile carriers. So option here in question 2 is 4. Question 3, unbiased PN junction diode at equilibrium, opposite carriers are crossing junction, or in other words we can say this is the diffusion current equal to drift current. They are equal and opposite, so effectively no current is flowing. Effectively no current is flowing. So option 2 is correct. And 4. And 4. Here the resistance at 15 milliampere. 15 milliampere current. We have to find out the resistance. Resistance in forward biasing, the active region, the voltage difference at 0.8 minus 0.7, the voltage difference and current difference 20 minus 10, that is in milliampere. So here 0.1 upon 10 into 10 to the minus 3. After solving, cancel out, cancel. So 10 ohm resistance means option hello. In this case 6 is the circuit here. The P region, N region, positive, negative. So it is forward biasing. In forward biasing, this diode will conduct and we are getting the current in the circuit. In the resistance here, after closing the key, we are getting the current. This a voltage barrier voltage here given 0.4 volt and depletion width is very less, 4 into 10 to the minus 7 meter, and battery voltage is given here 3 volt and current in the circuit flowing 20 milliampere. With this information we are discussing chance. So here question 1. Question 1. The intensity of the electrical field in the depletion region in case of unbiased condition, electrical field is given by barrier voltage, is the barrier voltage and is the battery voltage. So barrier voltage divided by the gap, barrier voltage 0.4 upon gap 4 into 10 to the minus 7. So it is a electrical field, cancel 0.1 per 6, 10 to the 6 volt per meter. So option correct. And resistance required here in the circuit, battery voltage 3 and here this voltage is 0.4. So resistance is 3 minus 0.4. This is the effective voltage divided by the current 20 milliampere. So this is 2.6 divided by 20 into cancel out 1.3, 0.3, so 130 ohm. This option is correct. Question 2, option 3 is correct. Now question 3. In question 2, option 3 is correct. Question 3. Voltage the potential barrier voltage is this, and with the applied voltage at what moment the barrier disappear. Means जब ये voltage applied voltage barrier voltage के equal and opposite होगा, means option correct. And 4. Here the electron is moving with initial speed 4 into 10 to the power 5 meter per second, and when it is reaching up to the P side, we have to find out the speed. We are using the conservation of energy. Means half mv square is equal to EV naught plus half m 2 square. We have to find out 2. Here mass 9.1 10 to the power minus 31. V1 is 4 into 10 to the power 5 square. V naught is 4 half m V2 square. After solving V2 comes here 1.39 into 5 filled. So here option correct.